Welcome to Study Session with the Data Lord. I'm starting the series because I know a lot of people ask questions like, how do you become a blockchain engineer, or how do you become a blockchain architect, right? So the answer is there's no easy button. It takes intentional sessions all the time. I'm just staying current and learning new things and diving in and reading technical papers and then testing your understanding and making sure that it's accurate. And sometimes the documentation's wrong. That sucks. But what are you going to do? You're going to approach it with the scientific method. And there's this approach where you inform yourself first. You just understand what the documentation says. And then when you test it and you find things that kind of hang you up, you can go on the, Discord or Slack channels or forums for that official community. And a lot of times there's people there who actually care and may not reply back right away, but eventually they do. And you just have to be kind of persistent about finding the right people and getting your answers and testing them. And yeah, so I want to kind of bring people on this journey. And today I am going through the documentation for the Cosmos network. We're trying to get a really firm understanding of Cosmos. There's a big ecosystem behind it. There's obviously staking nodes and all that. And that's what I'm interested in, at least getting into first. So I have this delicious hop tea. It's not alcoholic, but it tastes like an IPA. So, when you're trying to focus, at least for me, alcohol don't help. It chills me out too much and I lose my edge. So I, like the floral taste of this hop water. So, itadakimasu. So, let's do it. So, this is the official doc for Cosmos, right? So, we're just going to read through this together. And if this interests you, hang out. Soak up what you can, but I'll be doing this series whether you watch it or not, so that's too bad. Cosmos SDK, high-level overview. What is the Cosmos SDK? Cosmos SDK is an open-source platform. Oh, I got that wrong. Is an open-source framework for building multi-asset public proof-of-stake blockchains, like the Cosmos Hub, as well as permissioned proof-of-authority blockchains, like that. Blockchains built with the Cosmos SDK are generally referred to as an application-specific blockchain. It's dope. The goal of the Cosmos SDK is to allow developers to easily create custom blockchains from scratch that can natively interoperate with other blockchains. That's also dope. We envision the Cosmos SDK as the NPM-like framework to build secure blockchain applications on top of Tendermint. And so sometimes when you see these links here, if you use your scroll click on your mouse to click on it, it'll open in a new tab, and we can go over there and check it out. So this is Tendermint. So it's a Byzantine fault-tolerant state machine replication, or blockchain for short. So Tendermint Core is a Byzantine fault-tolerant middleware that takes a state transition machine written in any programming language and securely replicates it on many machines. That's dope. For protocol details, refer to Tendermint specification. Love to. So again, I did that middle mouse wheel scroll click. So looking over here, this is a markdown specification of the Tendermint blockchain. Defines base data structures, how they're validated, and how they communicate over the network. If you find discrepancies between the spec and the code that do not have an associated issue or pull request, blah, blah, blah. Okay. So, here we go. Tendermint provides Byzantine fault-tolerant state machine replication using hash-linked batches of transactions. Such transaction batches are called blocks, hence Tendermint defines a blockchain. Each block in Tendermint has a unique index, its height. Heights in the blockchain are monotonic. Each block is, I want to look this word up. So if you double click on a word like this, it'll highlight it. You can right click on that and you can go to search Google. So it didn't pop up on your screen, but it was on mine. So a monotonic is a mathematic term varying in such a way that it either never decreases or never increases. Okay. So it's a fixed number. Cool. So each block is committed by a known set of weighted validators. Membership and weighting within the validator set may change over time. Tendermint guarantees the safety and liveliness of the blockchain so long as less than 1/3 of the total weight of the validator set is malicious or faulty. Okay. So, in case anyone doesn't know what Byzantine fault tolerant means, basically Byzantine Empire. There's this example where there's two military generals that are at the same rank, and they're your superiors, and one guy tells you to go left, the other guy tells you to go right. Who do you listen to? Well, even though they're at the same rank, one of them's probably stronger or has some leverage, and you're probably going to listen to one even if it's by a marginal fraction, right? Like one guy knows what you did last summer or something, you know? So that whole idea applies to blockchain, starting with Bitcoin, where that's where the whole 51% attack concept comes from. It's like if you have 51% of the network hash rate, you have majority say, and so whatever block you submit, if you have 51%, is seen as, you know, the true history of the blockchain. So that's why all these miners are decentralizing the hash rate to keep, you know, the likelihood of one person ever getting more than 50% as infinitesimal as possible. So that's how these networks are secured. You got people all over the place trying to get paid and supporting the network security in the process. So Tendermint is a Byzantine fault tolerant, so it supports that like majority rule to secure the network. Cool. So Tendermint is basically the consensus mechanism. I will dig more into that in another study session, and we'll discover the mysteries of Tendermint. So SDK stands for Software Developer Kit. So SDK-based blockchains are built out of composable modules. I'll check that out too. What are these modules, huh? Oh. Okay. So we got auth modules, bank modules, staking modules, government modules. So basically there's different components of this blockchain that I guess you can interface with independent of the others. So we'll dig into the technicals on that later. But yeah, so it's basically their government model for like making changes to how the blockchain works. Staking for securing the network. Bank, I'm guessing that's lending. And auth is how you authenticate. Maybe that's smart contracts. We'll find out. So SDK-based blockchains are built out of composable modules, most of which are open source and readily available for any developer to use. And anyone can create a module for Cosmos SDK and integrate already built modules in a simple and integrate already built modules as simple as importing them into your blockchain. Okay, dope. So they built different pieces, and you can pull in the parts that are relevant to your application. What's more, the Cosmos SDK is a capabilities-based system that allows developers to better reason about the security of interactions between modules. For a deeper look at compatibilities, jump to Object-Capable Module. Don't think I will. What are application-specific blockchains? Great question. One development paradigm in the blockchain world today is that of virtual machine blockchains like Ethereum, where development generally revolves around building decentralized applications on top of an existing blockchain as a set of smart contracts. While smart contracts can be very good for some use cases like single-use applications, an example like ICOs, initial coin offerings, they often fall short for building complex decentralized platforms. More generally, smart contracts can be limiting in terms of flexibility, sovereignty, and performance. Yeah, it makes sense. Application-specific blockchains offer a radically different development paradigm than virtual machine blockchains. Yep. An application-specific blockchain is a blockchain customized to operate a single application. Developers have all the freedom to make the design decisions required for the application to run optimally. They can also provide better sovereignty, security, and performance. So this makes sense. Basically, it's not one size fits all. It's you pick and choose the parts that apply to you, and you're not using up resources that aren't critical to your use case, right? All right. So why the Cosmos SDK? Cosmos is the most advanced framework for building custom application-specific blockchains today. Here are a few reasons why you might want to consider building your decentralized applications with Cosmos SDK. The default consensus engine available with Cosmos SDK is Tendermint Core. Tendermint is the most and only mature Byzantine fault tolerant, that's what BFT stands for, consensus engine in existence. Okay. Interesting claim. I'm not really challenging it, just that's a big claim. It is widely used across the industry and is considered the gold standard consensus engine for building proof-of-stake systems. Okay. Cosmos SDK is open source and designed to make it easy to build blockchains out of composable modules. As the ecosystem of open source Cosmos SDK modules grow, let me read that again. That didn't make sense in my brain. As the ecosystem of open source Cosmos SDK modules grow, okay, yeah. Basically, as the ecosystem gets bigger, it'll become increasingly easier to build complex decentralized platforms. Yeah, that makes sense. So they're creating a standard. They're allowing it to be open source, and so any code people build can be rinsed and repeated, and so you don't got to build from the bottom up. The only concern I ever have with that approach is if ever there is a exploit and you're just copying and pasting someone else's code, those exploits exist all over the place, and so it's not a matter of being a deep concern, but watch out for that. Like if you're just copying and pasting stuff, and it gets outside of just development and gets into production, be careful to do proper pen tests and keep up with security, because no one wants their app to go sideways. Okay, the Cosmos SDK is inspired by capabilities-based security and informed by years of wrestling with blockchain state machines. This makes Cosmos SDK a very secure environment to build blockchains. Yeah, that makes sense. Again, just the security thing. It sounds like they're saying security is a deep focus, which I believe. But again, audit your stuff, right? Don't just copy and paste and hope that it's good. People are smart. Most importantly, the Cosmos SDK has already been used to build many application-specific blockchains that are already in production. That's dope. Among others, we can cite Cosmos Hub, Iris Hub, Binance Chain. Oh, dope. I didn't know Binance Chain was built with Cosmos. Okay. Make sure I heard that right. Most importantly, Cosmos SDK has already been used to build many applications. Okay, dope. Okay, I see you. So Binance Chain was built on the Cosmos SDK. No kidding. Terra, we won't talk about that. Their issue is just their leadership, really. Okay, cool. Getting started with Cosmos SDK. Learn more about the architecture of a Cosmos application. Heck yeah. We love architecture, right? Knowing all the different pieces of how a system's built and what roles they play and what functions they take over and in what order, like all that's the like inner workings of the clock. That's like how the whole machine works, right? So I know a lot of people might not care about that stuff, but man, that stuff gets me stoked. Like I get excited when I just learn about all the different functions moving and dancing and synchronous to build this art, beautiful piece of art that functions properly. It's so cool. So blockchain architecture, state machine. At its core, a blockchain is a replicated deterministic state machine. A state machine is a computer science concept whereby a machine can have multiple states, but only one at a time given. There is a state which describes the current state of the system and transactions that trigger state transitions. Given a state S and a transaction T, the state machine will return to a new state S. Okay. So it moves in a cycle. That's what that's saying. In practice, the transactions are bundled in blocks to make the process more efficient. Given a state S and a block of transactions B, the state machine will return to a new state S. So for each T and B, apply T. So that's how a blockchain works, by the way. Basically, each block has a hash function of the previous block, right? And that's added to the next block, to the next block, to the next block. So that's why blockchains are secure. It's like, even if you were to get 51% of the network and you were to attack and submit, some transaction that said, like, let's say I sent you $5 and some, nasty MacGyver hackers like, he sent me that $5, right? And he hacked the network to be like, 51%. He can send me that $5, that guy. He would have to get that in time, because if there's already blocks continuing to go on, he's already too late to the party and it's already accepted, and that bad 51% he had is worthless because he'd have to solve every block that happened, and it's too much math to get pumped out in one go. Conceptually, people can do it with quantum machines, like quantum computers, but I haven't seen that done yet, so who knows. So, in a blockchain context, the state machine is deterministic. This means that if a node is started at a given state and replays the same sequence of transactions, it will end up with the same final state. Yeah, makes sense. The Cosmos SDK gives developers maximum flexibility to define the state of their application, transaction types, and state transition functions. The process of building state machines with Cosmos SDK will be described more in depth in the following sections. But first, let us see how the state machine is replicated using Tendermint. I'd love to learn more about Tendermint. Let's talk about that. All right. Tendermint. Thanks to the Cosmos SDK, developers have to define the state machine, and Tendermint will handle the replication over the network for them. Tendermint is an application-agnostic engine that's responsible for handling the network and consensus layer of a blockchain. In practice, that means that Tendermint is responsible for propagating and ordering transaction bytes. Tendermint core relies on an eponymous, I don't know what that word means. Eponymous, let's see. Okay. It's an adjective given their name to something. Okay. So an eponymous Byzantine fault-tolerant algorithm to reach consensus on the order of transactions. So it relies on a given named Byzantine fault-tolerant algorithm. Okay, whatever. That word didn't need to be there. Thanks for adding a word that added nothing. Let's see. Tendermint consensus algorithm works with a set of special nodes called validators. Validators are responsible for adding blocks of transactions to the blockchain. At a given block, there is a validator set V. A validator in V is chosen by the algorithm to be the proposer of the next block. This block is considered valid if more than 2/3 of V signed a pre-vote and a pre-commit on it. And if all the transactions that it contains are valid, the validator set can be changed by rules written in the state machine. All right, sounds pretty straightforward. Tendermint passes transactions to the application through an interface called the ABCI. What the hell does that stand for? Let's look. Application Blockchain Interface. All right. So Tendermint passes transactions to the application through an interface called the Application Blockchain Interface, which the application must implement. So basically, the application blockchain interface is just a way that the application can talk to the consensus mechanism. So that's cool. It's just the networking between the two different pieces. So note that Tendermint only handles transaction bytes. Yeah. It has no knowledge of what those bytes mean. All Tendermint does is order these transaction bytes deterministically. So Tendermint passes the bytes to the application via the Application Blockchain Interface, ABCI, and expects a return code to inform it if the messages contained in the transactions were successfully processed or not. Okay, so here are the most important messages of the Application Blockchain Interface. So you can check transaction, which means when a transaction is received by Tendermint Core, it is passed to the application to check if a few basic requirements are met. Check transaction, check TX, is used to protect the mempool of full nodes against spam transactions. Yeah, that makes sense. It's basically a security check to make sure you can't just throw a bunch of trash in there. The special handler called the anti-handler. That's neat. Oh, okay, it's gas. Got it. So a special handler called the anti-handler is used to execute a series of validation steps, such as checking for sufficient fees and validating the signatures. If the checks are valid, the transaction is added to the mempool and relayed to peer nodes. Note that transactions are not processed. So, an example, no modification of the state occurs with the check transaction since they have not been included in a block yet. Yep. So, deliver TX. So when a valid block is received by Tendermint Core, each transaction in the block is passed to an application via deliver TX in order to be processed. It is during this stage the state transition occurs. The anti-handler executes again along with the actual message service RPC for each message in the transaction. So these RPCs, these are pretty standard across like all these blockchain applications. They're not just blockchain though, but it's remote procedure call. So it's when a computer program causes a procedure, a subroutine, to execute in a different address space. So this is kind of like how you interface with the blockchain. A lot of like blockchain apps you develop, they use RPCs to talk. Cool. So begin block, end block. These messages are executed at the beginning and end of each block. Whether the block contains transactions or not, it is useful to trigger automatic execution of logic. Proceed with caution, though, as computationally expensive loops could slow down your blockchain or even freeze it. Ooh, ouchie! You could block your blockchain, bro. It's nasty. Yeah, definitely watch that one. You ever do that? Make a command prompt that opens a command prompt that opens a command prompt that opens a command prompt, and just does that until the computer crashes. I have some friends that they'd go to like Best Buy, and they'd make a batch file that would do that, and they'd save it in like the startup folder. And so, and then they'd hide it too, so that it couldn't be seen unless someone hit show hidden files. And so these poor dudes that, you know, it's funny. All the Geek Squad guys over at Best Buy, they'd be like, "What's happening?" There's just command prompts blowing up all over. They reboot the computer and it happens again. So it's pretty funny. You don't want that to happen to your blockchain. That's the point, right? Also, don't be a menace to society. Okay. Man, I drink like an animal. Freaking tea on my beard. Crazy. All right. So, find a more detailed view of the application blockchain interface methods for the Tendermint docs. Let's check that out real quick before we go on. Oh, nice. A little 404 action, so I guess we won't. Any application built on Tendermint needs to implement the application blockchain interface. I love that. ABCI. The I stands for interface. It's like an ATM machine, an automatic teller machine. In order to communicate with the underlying local Tendermint engine. Fortunately, you don't have to implement the application blockchain interface. Cosmos SDK provides a boilerplate implementation of it in the form of BaseApp. Okay. I don't know what BaseApp is, but we can take a look. BaseApp is the boilerplate implementation of Cosmos SDK. Comes with an implementation of application blockchain interface to handle the connection with the underlying consensus engine. Typically, a Cosmos SDK application extends BaseApp by embedding it in the app.go. Okay. Basically, they give you some tools to work with, just in the basic install. Cool. So, just reviewing this real quick. That's how I get stuff kind of cooked in my brain. So we have state machines. That's how it handles Byzantine fault tolerance, right? It applies every block to every block. In the future, it's deterministic. Pretty much all blockchains are that way. So Cosmos SDK gives developers maximum flexibility to define the state of their application, transaction types, and state transition functions. So we can kind of pimp our ride however we want. And we use the application blockchain interface to pass transactions. Okay. Yep. We're good. So let's get to this main components of the Cosmos SDK. So the Cosmos SDK is a framework that facilitates the development of secure state machines on top of Tendermint. At its core, Cosmos SDK is a boilerplate implementation of application blockchain interface in Golang. Dope. Comes with a multi-store to persist data and a router to handle transactions. Okay. Here's a simplified view of how transactions are handled by an application built on top of the Cosmos SDK when transferred from Tendermint via the Deliver TX. Remember we saw that deliver transaction. That's one of the things that the blockchain interface can do, right? So simplified view of how transactions are handled by an application built on top when transferred via Deliver TX. Okay. So when we deliver TX, we decode a transaction received from the Tendermint consensus engine. Tendermint only deals with bytes. It extracts the message from transactions and do basic sanity checks. And then you route each message to appropriate modules so that it can be processed and we commit state changes. Okay. So it decodes the transaction and it's just looking at raw data. It extracts the messages from the transactions and then it routes each message to its appropriate module. So basically what this is doing is it takes the transaction and just pulls it apart and sends each relevant piece to the module that it should go to. So it's like parsing it. And then it commits the state change. Got it. So base app. Base app is the boilerplate implementation of a Cosmos SDK application. It comes with an implementation of the application blockchain interface to handle the connection with the underlying consensus engine. Typically, a Cosmos SDK application extends base app by embedding it in the app.go. I didn't get a good feel for what app.go is. Let's check that out. So core application file. So in general, the core of the state machine is defined in a file called, okay, it's a file. Got it. So app.go is a file that defines the state machine. Okay. Contains the type definition of the application and functions to create and initialize it. Okay. Yeah. This is like the config for the app, basically. Okay, dope. So with that context, let's read this again. So base app is the boilerplate implementation of a Cosmos SDK application. It comes with an implementation of the application blockchain interface to handle the connections with the underlying consensus engine. That's like the bare bones, basically. Typically, a Cosmos SDK application extends base app by embedding it in that file. Right, app.go. Okay, so it seems like you're almost like declaring at the top of this config file app.go just all the extra pieces that should be there. So here's an example of this sim app, the Cosmos SDK demonstration application. Okay, so type is sim app. It's a structure. got the base app. It's got a legacy amino. I don't know what that is. Codec legacy amino. App codec. Codec. Interface registry. All right. I'm sure this will make more sense if we just keep going. So the goal of base app is to provide a secure interface between the store and the extensible state machine, while defining as little about the state machine as possible, staying true to the application blockchain interface. So the goal of base app is to provide a secure interface between the store and the extensible state machine, while defining as little about the state machine as possible. Okay. So basically what I get from that is it's least information necessary, and it secures the different base components of the application so they can talk to each other, but there's not more talk there than needs to be there. Multi-store, drink. All right, multi-store. So the Cosmos SDK provides a multi-store for persisting state. Multi-store allows developers to declare any number of KV stores. These KV stores only accept the byte type as a value, and therefore any custom structures need to be marshaled using a codec before being stored. The multi-store abstraction is used to divide the state in distinct compartments, each managed by its own module. For more on the multi-store, click here. Yeah, I want to know more about this, man. That did not make enough sense to me. And I'd love to get a better understanding. So again, use the mouse scroll. If you click on that, using the mouse scroll, it'll open a new tab. So got to get proficient at being able to dig deep. A lot of times the answers aren't just right in front of you. You kind of have to go, let's define that. And then you put all the ingredients on the table. Then you can get your pan hot. You can get cooking, right? But it's kind of like, when you're cooking, if you don't get all your ingredients right, and you get that pan really hot, and you're like, oh crap, I got to chop garlic. And you go and chop garlic. You might burn something else in the pan by the time the garlic's done, So it's best to if you look at techie stuff as cooking, cause you're basically cooking. You're taking different ingredients, different elements, and you're processing them in such a way and configuring them in such a way and applying, in cooking's case, heat and technique, and in techie speak, you're applying, machines and operating systems and application configurations and network configurations and tying all that stuff together in harmony, and then you end up with something that you want to eat, something you want to, an app you want to use, right? So, but don't eat too many applications or you'll get a tummy ache. All right. So let's read about multi-store, huh? Multi-store interface. So each Cosmos SDK application holds a multi-store at its root to persisted state. Multi-store is a store of KV stores. What does KV stand for? I don't know. Search Google. Maybe add blockchain to it. KV stores, blockchain. I want to say it's key vault, but I don't know if that's true. Key value. Okay, dope. We got an answer right there. See that? Key value. The Tendermint core answer. So. Yeah. See, that wasn't that much digging. And we got our answer right here. So Yeah, that makes sense. KV app is a Merkle tree that just stores all transactions. So if the transaction contains equals, then key equals value. Then the value is stored under the key in the Merkle tree. So if you want to understand a Merkle tree, so in cryptography and computer science, a hash tree or Merkle tree is a tree in which every leaf or node is labeled with the cryptographic hash of a data block. And every node that is not a leaf, called a branch, internode, or inode, is labeled with the cryptographic hash of the labels in its children nodes. A hash tree allows efficient and secure verification of contents of large data structures. A hash tree is a generalization of a hash list and hash chain. So even Bitcoin did this, where this actually might help illustrate how some of this stuff works. So here we go. I'll make this a little better photo screen. Man, hold up. I got you. That ain't it. I got you. Yeah. So this is how this works. So you have, these different data blocks here. So leaf 1, leaf 2, leaf 3, leaf 4 at the bottom. And then each of those go into their own hash, right? So you have hash 00 is what L1 goes into. Leaf 2 goes into hash 01. Leaf 3 goes into hash 10. Hash 4 goes into... leaf 1 goes into hash 11. And so we can basically, instead of like having all those written out long form, what we can do is make the next. So look at hash 00 and hash 01, right? These second from the bottom. So the way that hash 0 is calculated is we have hash 00 and hash 01 as part of that mathematic function, and that's what makes hash 0. So like I was saying, that's what keeps it like a blockchain secure. It's like, let's say you were to hack like top hash, well, you'd still have to make up for all the ones you missed behind it, if that makes sense. So you got to have a lot of power. You have to move really quick. And most of the time, if you have that much power, you're not quick, right? There's just too many details to keep track of. So this is how like a Merkle tree functions, right? So seeing it explained. So the key value store app is a Merkle tree, okay? That just stores all transactions. So if the transaction contains an equals, an example key value, then the value is stored under the key in the Merkle tree. Otherwise, the full transaction bytes are stored as the key and the value. So, yeah, I'll find some nice ways to maybe make a video just on like explaining Tendermint. But we're doing Cosmos, so back up the bunny hole. Let's yikes. Don't do that now. You know what I mean. Get back on track. Get back on the trail. So we got my mouth is dry, so I'm gonna drink something. See, we're having fun. We're having some fun here. We're learning. We're vibing, and that's important, right? I really do love this stuff. It's like meditative, like we can like just kind of keep introducing all these like neat ideas to our brain, and you kind of have to like approach this type of technical research as like philosophical, like you have to instead. You might hear this phrase where it's like it's not about the destination, it's about the journey. that kind of applies here, where it's like, don't be so obsessed with the destination, because there's a long road. like if you could find ways to just get your mind and body and your spirit like prepared for this type of research, like, yeah, there's fog, there's stuff we don't know. Be patient with yourself. Just open up, open up the tabs as you're asking questions, answer them, return back, reiterate what you just learned, and keep moving. And it's like you kind of have to allow that fog to sit in, and just to realize how much, like, oh wow, I really have to go down all those different rabbit trails in order to fill in my understanding. Like, I have a lot to learn, and just be patient with yourself. Go down those trails, understand it, put all the pieces back together, get back on track, see if it makes sense now. If it doesn't, review again the part that you didn't quite understand. Sometimes you might have to go, down the search engine trail as well, and try to find some other sources that might talk about it. But that's how this stuff works, right? We're bushwhacking. There's not a clear trail blazed just yet. Thankfully, this is really good documentation, right? Not every blockchain has this type of documentation. I've had some I've researched that you could tell that the people who wrote the documentation just assumed you knew a lot of the things that they know, because they've just been eating, sleeping, breathing this stuff for so long that they kind of forget, like, what base information other people might not be coming to the conversation with. So this is shout outs to Cosmos. This is really good docs. Although I've seen you say application blockchain interface. It's too many interfaces. One too many. Yeah. So anyways, be patient with yourself. Enjoy the journey, please. Make sure you have good drinks, right? Make sure, if you can, get a space you really enjoy. Make sure you have music that kind of sets a vibe for me. I love working to chill hop and, chill step, lo-fi. It just kind of becomes background music for what I'm doing. Also, if anyone's interested, these headphones, these are the Bayer Dynamic DT770s. So these are open back. At least these are 990s maybe. Yeah, I'm wearing my 990s. The 990s are open back. The 770s are closed back. So it depends if you want to hear what's going on around you or not, right? I have dogs. I got 3 little beagle mixes. And I like hearing if they're barking at something. I need to be like, hey, quit. So the open back helps me out. But yeah, get comfortable, man. Enjoy the journey. So let's get back to it. So multi-store interface. Each Cosmos SDK application holds a multi-store at its root to persisted state. The multi-store is a state of key value stores, we know that now, that follow the multi-store interface, okay? So type multi-store interface, curly brace store, branches multi-store into a cache storage object. Color should probably not call right on each, but cache multi-store, right? I don't quite understand that. Okay, so convenience for fetching substores. If the store does not exist, it panics. Tracing enabled. Returns if tracing is enabled for multi-store. Set tracer sets the tracer for the multi-store that the underlying store will utilize to trace the operation. Modified multi-store is returned. Set tracing context. Set the tracing context for a multi-store. It is multi-store that the caller should update the context when necessary between tracing operations. Modified multi-store is returned. Okay, so there's setting conditions. I get you. If tracing is enabled, then branching the multi-store will firstly wrap all the underlying key value store in this file here. Okay, what's that file do? Trace kv.store is a wrapper. KV store, which provides operation tracing functionalities over the underlying KV store. It is applied automatically by the Cosmos SDK on all KV store if tracing is enabled on the parent. Okay. When each KV store methods are called, trace kv.store automatically logs trace operations to the store.writer. Trace operation.metadata is filled with store context when it is not nil. Trace context is a map string interface. Okay. This isn't making too much sense to me yet. I'm sure it will. And once I do, I'll explain it. But let's go back up the bunny. Yikes. Let's get back on track. Okay, bud. We were on here. So, yeah, multi-store, we basically saw you can set like conditions. So modules. Power of the Cosmos SDK lies in its modularity. I'd love to hear more about that. Cosmos SDK applications are built by aggregating a collection of interoperable modules. Each module defines a subset of the state and contains its own message transaction prior. Each module defines a subset of the state and contains its own message transaction processor, while the Cosmos SDK is responsible for routing each message to its respective module. Okay. Here's a simplified view of how a transaction is processed by the application of each full node when it's received in a valid block. So the transaction relay from the full node's Tendermint engine to the node's application via this DeliverTX, which is part of the application blockchain interface. Application. Using base apps methods, decode the transaction, extract and route the messages. So it routes all those different pieces over here. Message routed to the correct module to be processed. That's dope. It goes to government module, handles message, updates the state, and return results to Tendermint. Yep, cool. That all makes sense. Hope it makes sense to you. Basically, transactions go through a full node, Tendermint engine to the node's application via this application blockchain interface deliver transaction. So that then basically goes through like the networking of the blockchain. It goes to the application, which will take the transaction that just went over the network. It extracts and routes, and sends it to all these different pieces. So to the auth module, the bank module, the staking module, and the gov module. And then it checks out, and that makes a block, and then it does it again. All right. Each module can be seen as a little state machine. Developers need to define the subset of the state handled by the module, as well as custom messages. As well as custom message types that modify the state. Note, messages are extracted from transactions by base app. In general, each module declares its own key value store in the multi-store to persist the subset of the state it defines. Okay. Most developers will need to access other third-party modules when building their own modules, given the Cosmos SDK is an open framework. Some of the modules may be malicious. Yeah, that's what I was warning people about. Like, if people are doing their own, bro, just read your code, man. Know what it's doing. Which means there's a need for security principles to reason about intermodule interactions. These principles are based on object capabilities, okay? In practice, this means instead of having each module keep an access control list for each other module, each module implements special objects called keepers that can be passed to each module to grant a predefined set of capabilities. Okay, cool. So what this is saying is there's basically a way to assign like least privilege, right? Using these keepers, apparently. So you'd be like, okay, you can only go down the street on your bike with your brother Jimmy. Once you get to the end of the block, you gotta turn around and come back. If I catch you trying to do anything else, you're grounded. No more Xbox. You know, it's that kind of thing. If that's weird, that was my life growing up. So Cosmos SDK modules are defined in the X folder of the Cosmos SDK. Some modules include, okay, cool. XAuth, which is used to manage accounts and signatures. XBank, which is used to enable tokens and token transfers. XStaking and XSlashing, used to build proof-of-stake blockchains. Oh, I see you. In addition to already existing modules in X that anyone can use in their app. So there's a bunch of stuff in this X folder. And then also there's modules defined in the X folder for managing accounts and signatures, enabling tokens and token transfers, and building proof of stake. Cool. Nice. So that was the introduction. I'm going to keep going, but I'm going to stop the video here. And so if you want to see more, click the video that's popping up here, I'll even do this for you. I will. Check this. Hello. So that was the Cosmos SDK introduction, plus all my goofball commentary. So, click the video. I think it's there. I think that's the video. We'll go over basics.